We're on a section of the Mahi River, upstream of where we stopped earlier this morning. And we've come to this point because at some of the other stops we've been talking about these erosional gully features known as ravines in this context. This is where one of these ravines carrying a load of sand and some minor gravel enters into the main channel of the Mahi. And you can see it's bringing in a fan of material that's spreading out onto this low bench or floodplain above the channel that we can see there in the far distance. I'm going to turn to Anukritika Raj here, PhD student at Indian Institute of Technology, Gandhinagar, working under Professor Vikrant Jain, who's surveyed the cross-section at this particular point. Can you tell us what you found at this particular point?
Okay, so coming to the cross section, it was around 550-meter wide and about 15-meter depth. If you can zoom here, in this part where we have the main channel flowing, and also in this patch we could see patches of basaltic rock here. And coming to its river styles, mainly we have terraces just like the one that we had in downstream, and yeah, that's all.
Okay.
And there is feature and ravines, of course, so the features continuation is there.
So there's
Terraces
bedrock control certainly on the channel bed,
yeah, definitely.
but the banks are dominantly alluvial from
Yes.
these.
You can.
What was the season when she did?
Yeah.
So I did in pre-monsoon, that is around April. I took the cross section, and March or April, and at that time I was able to. If you could just move there, you could see the bedrock exposure there. So we basically followed that trail and took the cross section, and we easily took it. And also on the left hand side there was deeper sections due to sand mining, which is very prominent in this area, which is also kind of changing its morphology. So that also we got in the cross section.
So there was no water in the cross section at that time, or just pools?
No, just in this main part we had some water.
Okay.
And people were having recreational activities here.
Okay.
So they were having picnic and stuff. So yeah, that's
okay. So that's the low water dry season. So I'm going to turn to Professor Jain and ask him some questions about what flow conditions are like at peak flow during the monsoon season.
Yeah, so I have discussed with the local people, and I find out these two major processes. First is that during high flood period, it reaches very close to the bridge area, so up to maybe 2 or 3 meter lower than the bridge. So a river has a tendency to get a flash flood, and we can assume that kind of stream power, and that's why there is not much of the sediment. We can see the bedrock which are exposed in this region. Second part, important thing, they told that earlier the river water used to go over the terraces where the houses are there. So villages were affected by the flooding hazard. But now, because this bed level has been lowered, and that is due to sand mining, so anthropogenic effect has also lowered down the bed level, and now there's flood water no more going up to the river terraces. So originally it shows that or like natural wise, this surface is not exactly terraces, they were also part of the floodplain, and it's a combination of the natural process, which is climate change, that was responsible for this in season, as well as anthropogenic impact. Now the surface has become terraces part, and maybe this is the reason that we are seeing the rejuvenating gully erosion development. So when we are coming around, we have seen the different processes, very fresh processes. So it looks like a new set of gullying has been started on the surface.
Okay. So that's roughly 20 meter.
Roughly 20 meter.
Roughly 20 meter rise. I mean, significant stream power in a 500 meter wide confined section.
So it can able to transport all this.
So I think we can walk along and maybe look at examples of some of the bed load material that's transported, and also some of the bedrock erosional processes. So we'll follow the trail along the channel here. These are alluvial sediments I think have become cemented at the base, so I can probably, yeah, they're well cemented, so I don't think that's bedrock as such, but we will come to bedrock shortly. So if you can see in the distance there, that black outcrop, that's basaltic bedrock cropping out. We'll just cut down here.
And these are some water harvesting structures on the river. They are pulling water directly from river using this column and that column.
Okay, so some of this material here is material that's moved by flood flows. Whole chunks of basalt bedrock, which have broken off the outcrop. Large chunk there, very heavy. Then there are rounded gravels, which we've seen at other places along the river. All kinds of lithologies.
Yes.
But nicely rounded. Some of these are basalt, some are other lithologies, including quartzites. And if we look at the surface of the bedrock itself, we can see a variety of erosional processes going on. Obviously, chunks of the basalt are breaking off. So the surface of basalt is very dark, as you can see, and it physically and chemically weathers in this kind of climate, particularly with the exposure to the sun. It heats up. These are quite warm to the touch. You know, it's actually quite hard to squeeze them because they're so warm. And on a really hot day, you can imagine this rock surface heating up to 50 or 60 degrees, cooling down at night, heating up again during the day. Constant expansion with heating, contraction with cooling can lead to these surface cracks and fractures forming, which the river then during high flow will exploit and break off whole chunks, and these chunks become part of the river's bedload. If Manu just pans around as well, we can see localized abrasion as well in the form of these depressions, and another one here. If these were to develop further into more pronounced semicircular holes that drill a little bit deeper into the bedrock, you could call them true potholes. These are sort of incipient potholes that may or may not continue to develop under the action of the river flow. But anyway, that gives you some idea of how the river is attacking the bedrock and adding to the sediment load that it already has.
So we are seeing physical weathering processes here.
There's physical weathering processes, yeah, I think that's predominating on these rock surfaces, but undoubtedly there could be chemical attack of the rock as well. So there are calcite veins running through this rock mass. There's small examples here. There's a better example over here. You can see these white veins. So that's calcite, calcium carbonate, which under slightly acidic rainfall or river waters can dissolve, and then the calcium ions and the carbonate ions would form part of the dissolved load of the river. And I think Professor Jain was telling us earlier that that's a major component to the dissolved load of the river.
Okay. Thank you.